Okay, I put bonding up here, and we're going to do bonding quickly. Okay, now, in order to understand bonding, you have to understand a word that I'll define. It's called electronegativity. Electronegativity is simply this. It's a tendency for an atom to be attracted to bonded electrons. The higher the electronegativity, the more it wants those electrons that make up the bond. Okay? So, if this is a periodic table, we'll just make it a quick rectangle. Going from the lower left to the upper right, electronegativity is increasing. So if you look at your periodic table, it goes like this, where this element up here is more electronegative than these elements down here. These are the lowest, these are the highest. It doesn't include the noble gases, but fluorine has the highest electronegativity. Clear? Now, if the difference between the low electronegative element and the high electronegative element is big enough, it rips the electron from the higher electronegative element, rips the electron from the lower electronegative element, such as this. Here's sodium and here's chlorine. Now, in the first shell, you can put 2 electrons, 8 electrons in the second shell. Sodium has 11 protons and 11 electrons in what we call the ground state. Ground state, unreactive state, for instance. Okay? It hasn't bonded with anything yet. It wants to get rid of that electron, and the reason it wants to get rid of that electron is this. That look where sodium is. Sodium is here, right? Sodium is there. Yes? It has 11 electrons. If it gives up 1 electron, it's like neon here. This has 10 electrons. Neon is a noble gas. All elements react so they don't have to react. They react to become stable. They react to become like a noble gas. Yes? The electron structure. It only affects the outermost electrons. This shell here, this shell here. Clear? Those are called valence electrons. Valence electrons are the outer electrons. Chemistry can be defined by changes that occur within the valence electron structure, period. That's chemistry in 1 sentence or less. So you have to key in on the valence electrons. Why the valence electrons? If I make an atom that looks like this, here's an atom, right? Here's an atom. If they touch, what's touching? The outermost shell of electrons is touching. Clear? So that's what you have to key into, is the outermost electrons, called the valence electrons. And in this case, this has a very low electronegativity. This has a very high electronegativity. So the electron is ripped. Chlorine will gain 1 electron to be like argon. Sodium will give up 1 electron to be like neon. So it's going to look like this. So this shell here disappears, and then this gains an electron. This gains an electron. So now it's still chlorine because it still has 17 protons, but it now has 18 electrons. This has 10 electrons. This is like neon. This is like argon. That's ionic bonding, where you have the complete and absolute transfer of electrons from one element to another. as opposed to covalent, which is more sharing. So here's covalent bonding. Chlorine is more electronegative. Hydrogen is not terribly non-electronegative. So there's a sharing, but look at this. You see how chlorine has a higher electronegativity, so it's going to attract those electrons a little bit more, creating the shift in the electron cloud? Well, that shift creates a polarity. We'll talk about polarity more in the next video, but it creates a polarity. And that polarity is called the dipole moment. It's a big word, I know, don't worry, but it's called dipole moment, which is a shift in the cloud. Shift in the cloud creates polarity. Like Democrats over there, Republicans over there, boys over there, girls over there. You're creating a difference between the two groups. Clear? You're creating a polarity by having this shift. Now look at this. This has 7 electrons plus 1 is 8. Helium has 2 electrons. Hydrogen has 1. Helium is a noble gas, but how many electrons does hydrogen have now? It has the original 1 plus it shares that. So they both share electrons. You get it? Mm-hmm. So, chlorine is now like argon. Hydrogen is now like helium. So it's stable, but polar because of that shift in the cloud. Now, when you make a particle using covalent bonding, that individual particle is called a molecule. I wrote it here somewhere. Here, molecule. An individual particle as a result of covalent bonding is called a molecule. You get it? Mm-hmm. An individual particle that results in ionic bonding is called a formula unit.
Yes.
So this one particle, I have plus 1, minus 1. Yes? Because I have 10 electrons, 11 protons, plus 1, 17 protons, 18 electrons, minus 1. That's a formula unit. Whereas this HCl is a molecule. Understood? So, we've done valence electrons, we've done covalent bonding, ionic bonding, we've done electronegativity, molecule, formula unit. I think that's enough. Clear?